Hello everyone. In this presentation we are going to understand how to interface a switch with an LCD display. So here now LCD display is displaying volume equal to 000, which is assuming like the volume in the television receiver. So now the TV is muted. Now we have to increment the volume, means I am pressing a switch to increment the volume. So you are able to see the volume is getting incremented. In the LCD display, if you see, it is displaying 4, 5, 6, 7, 8, 9, 10, 11, 12. So the volume is keep on incrementing. When I am pressing the switch is connected to P2.0. When I am connecting the switch which is connected to P2.1, the volume should decrement. Now it is showing 21. Now when I press the other switch, where you are able to see the volume is getting decremented from 21 to it is towards 0. So here the LCD display is connected to port 0. If you look at the hardware details, the LCD display is connected to port 0. So as you see here, port 0 of the microcontroller, and we have register select, read, write and enable are the three pins, are the three control signals, are the three control pins to the LCD. So those register select is from P2.0 as you see here. This is red wire, and the read write is this black wire, and the enable is another red wire. So register select, read write and enable are the three control signals for this LCD. So LCD needs 11 GPIO lines. One is parallel port where the LCD is interfaced with the microcontroller through port 0, which is a parallel data. And then there are three control signals, P2.0, 2.1, 2.2 are connected to the register select, read, write, enable of the LCD, which are the mandatory. And as usual, the two switches, one is volume up switch which is connected to P2.0, so 2.4. So here the volume up switch is connected to P2.3 and volume down switch is connected to P2.4. So because 2.0, 2.1, 2.2 are for LCD, 2.3 and 2.4 for volume up and volume down. So these are the interfacing. So two input GPIO lines and 11 output GPIO lines to interface LCD, which helps us to increment or decrement the key press value. So where here we use LCD where alphanumerical values can be displayed. Say for example, there is a possibility for us to show the volume. So all the uppercase letters. So volume equal to all the special symbols can also be displayed, as we see here in this LCD display, which is much more user friendly when we use LCD display in our application or project. This is how it is being interfaced. These are all the hardware setup. So let us look at the code here, which will help us to understand much more. Coming to the code, here you see, as usual, we start with the initialization with #include reg51.h, and the LCD is initialized. So there are three control signals for the LCD: register select, read write and enable. Register select, read write, enable. Register select is connected to P2.0, read write of LCD is connected to P2.1, enable is connected to P2.2, and our volume up switch, which is switch 1, is connected to P2.3, and volume down switch, which is connected to switch 2, which is connected to P2.4. So there are 5 general purpose input output pins, 3 for control signals of the LCD, and then 2 for volume up and volume down button. So this is the bit set resettable feature in the microcontroller. 5 GPIO lines are used independently for different purpose. Here three pins are for control signals of an LCD, and the 2 pins are for giving the input signal through the switch. Okay, so there are variables because we need to convert binary to BCD. So ones, tens, hundreds. So the two variables. So how many ones, how many tens, how many hundreds, and there is one temporary variable, and as usual there is a C variable for us. And as usual we do a small delay routine, and this is very interesting. So there are command signals and there are data signals. For the command signals, there is a command function. So the only difference is when the register select is 0, it is a command function. When the register select is 1, it is a data function. So read write is 0 means microcontroller is writing into the LCD, and then when we are making enable 1 to 0 means, so the LCD will accept the data as well as the commands. So there is one function for command. So which row, which column, for that we need a command. So LCD accepts American Standard Code for Information Interchange. So the ASCII data can be sent out through this data function, as we see here. So the initialization of the LCD is being done here. The initialization of the LCD is being done here. How to initialize LCD? The first way of initializing LCD is 38 means 2 lines 5x7 matrix, as we know very well. And the another control word is 0x0e, which is to make the display on and the cursor blinking. And CMD01, the 01 is the command for clearing the screen, and 06 is the command for incrementing the cursor. So these commands will initialize the LCD. After that, as usual, this function will increment the key. As usual, this function will decrement the key. When I press the key, the switch will be, the pin will become 0. So it is decrementing. Okay. So the C variable is getting incremented when I press the volume up switch. The C variable is getting decremented when I press the volume down switch, as we see here. So here, because we are connecting an LCD accepts ASCII. So there are two code conversions here. One is binary to BCD as usual, as we see here. So the C variable is binary variable, and the binary value is converted to binary coded decimal, like ones, tens, hundreds. So if the C variable is divided by 100 means the quotient is hundreds. So that is stored in the 100 variable, and then the remainder is stored in the temporary variable. So if the value is 255 means the remainder 55 will come to the temporary variable. So the temporary variable, that is 55 divided by 10 means what? The quotient will be 5. So the 5 will go to tens and the remainder is ones. So converting the binary value to ones, tens and hundreds is being done here in this code, which is binary to BCD code conversion. After binary to BCD code conversion, we have to convert that ones, tens, hundreds into ASCII. Why? Because the ASCII equivalent of the decimal number is adding 0x30 to it. So 100 is this 100 is a BCD value, which its ASCII equivalent means by adding 30 to it. So this 100 variable is updated with ASCII value. So adding hexadecimal 30 to the variable will convert the BCD value into ASCII value. Say for example, 30 is the ASCII value for displaying 0. 39 is the ASCII value for displaying 9. So decimal number 0 means in the ASCII equivalent is 30. Decimal number 9 means ASCII equivalent is 39. So 0 to 9 decimal number in is 30 to 39 in ASCII. So that is why we are adding 30 to all the ones, tens, hundreds and variables, and then you are sending out the data through the command. So 80 means what? First row, first column. From the first row, first column, we are displaying volume first, and then on blank space. So as we know, in a single quote, if we give something means its ASCII equivalent will get transmitted. So LCD will accept the ASCII codes, and as we see here, hundreds, tens and ones. As we see here, first you are sending hundreds, then tens, and then ones in the corresponding segments in the first row. So this is how the code is functioning. So with the help of this code, we are able to display the corresponding volume similar to our LCD, similar to our TV remote. So when I am pressing this up arrow mark, the volume is keep on incrementing, as you see, as like how do we do in the television receiver when you press the volume down button. So the value is keep on decrementing. So as like how we do it in the television receiver. So this is how we have to interface a switch with an LCD display, where the input device processing and then output is happening. That is being discussed and demonstrated here. This is how we have to interface a keyboard and LCD. Thank you very much.